The data frame is the most important API of Apache Spark. And the data frame is not only an API, but it's one powerful distributed data structure. Usually we create data frames by reading existing data, and the data can be stored in a relational management database system or in a cloud storage system. But when we are writing applications, from time to time we would like to test our application with specific structured data, or just to create our own data frame manually and see how our source code will then behave. In this video, we will see how we can create data frames manually. First, we will start with how to turn a range of data into a data frame, and after that we will see how we can then get a list of objects in Scala and turn that list of objects into a data frame. I'll be writing my code inside the Databricks programming environment, and you can see here that the source code will be running Apache Spark 3 on the Apache Spark 3 version and Scala 2.12. So let's start with how to create a data frame using a range of number. So we know that in Scala, to create a range of number, we can do something like 1 to 10, and this will create a range with number from 1 to 10 that we can then easily print using the for each. And this will go ahead and then print number from 1 to 10. We can also do that with number from 1 to 100, for example. You can also create 1 using the until. And this will go ahead and create number till 99. So one thing we can then do now, let me remove this. We can turn this range of number into a data frame using the toDF method available to us. And this will return a data frame to us with one column with the data type integer. We can take a look into the data frame using the show method. There you go. This will print the first 20 values available inside our data frame. So now, as you can see, the data frame has only one column and the name of the column is value. We can change the name of this column by using an overload of the toDF method that takes an argument, and then we can change the name of the column by specifying another name. For example, we say we like the column to be named ID, for example, and this will go ahead, create a new data frame for us, and the only available column we have the name of ID, and this is exactly what we did. We are seeing here. Now we can take a look into it again, and we see that here the name of the column is now ID. Apache Spark also comes with a built-in function that allows us to create data frames from a range of functions, and the name of the function is the range. So from the Spark session, we can go ahead, do something like spark.range, and with the range function, we can do the same thing as we did before. We specify the start of the range, the end of the range, and eventually also a step. But first, let's start with this, and then we can take a look into the data frame. And this returns a data frame with the name with one column, and the name of the column is ID. Of course, here you can also rename the column using the with column rename. Let's say we like to rename the ID to key, for example. This is how we can do that. Then we go ahead, create a data frame with one column, and the name of the column will be key. So we can then do that, and this will display the data frame to us. To be able to use the toDF function, you must import Spark implicit. So inside the Databricks environment, Spark implicit are already imported automatically. But if you are writing your source code inside any IDE, then you will have to import Spark implicit directly before you use the toDF function. For example, inside the Scala Spark shell itself, you can see that you can check it here with imports, and then you will see that the Spark implicits are already imported. And this is quite important because if you are writing your source code inside an IDE and try to use the toDF method, then this might fail because the implicit are missing. So make sure you import Spark implicits when you are working with an IDE. But if you are using the Spark shell or even the Databricks programming environment, the implicit are already imported for you. So next, let's see how we can then convert a list of objects also into a data frame. So we can also use the toDF method. So we can do something like this, a list of 1, 2, and 3. Now we can use toDF, and this will also convert this one into a data frame. Or we can do a list with objects. Now we can do 1 and 1, for example. Now we say 2 and 2. So now we have two objects that we can then transform into a data frame, for example. Now this will return a data frame where the column names are automatically named like this: underscore first row, underscore first column, and then underscore second column. But if you only have one element in your list, then the name of the column will be value. You can change this by using the overload of the toDF function. Now you can say the first column name is ID and the second column name is, let's say, name, and execute that. Now we have two data frame where the first column, we have a data frame with two columns. The first column name is ID, the second column name is name. We can display our data frame using the show method. As you can see, it creates a nice data frame with 1 and 2 for us. Of course, we can also use a sequence of objects instead of a list itself. We can go ahead and just specify that we like it to be a sequence, execute it like that, and it will have exactly the same result. So what Apache Spark is doing here, it will take each object inside our sequence, and the object will be one row inside our data frame. But we know that a data frame has column, and all the value of a column must be of the same data type, which means if we go ahead and do something like this, 1, and then we come here and insert a string, for example, like this, this will not work because the column, the third column inside of our object is of type integer in one row, and in the other row it's of type string. So let me show you how this will behave. I just called this wrong, and you will see there is no encoder for any, because now you have rows of type any, and Apache Spark does not support that for now. So if you want to create a data frame using object, make sure that all the objects have element or columns of the same types. So let me remove this, this, and also this. Let's say var, let's call this df equal that. So we know that the data frame has a schema, and the schema of a data frame defines the name and the data type of the columns. Using the toDF function, we can specify the name of the column, but we cannot specify the data type of the column. To be able to define the data type of the column, we must use another function or another method that is available on the Spark session. This is the createDataFrame function. We can see how the DataFrame function works if we go to the Apache Spark official page, we go to the API documentation, then we select the programming language we are interested in our case this is Scala, and then we take a look into createDataFrame. Here you have the Spark session, and then you can see that there are multiple overloads available to us, and the most easier one that I find to use is this one, where I can specify a list of row and a schema. You can see the schema is of type struct type, and here you can just specify a list of row. Of course, it's not taking a Java list, a Scala list itself, but it takes a Java util list, which means we'll have to use some Java converters to convert a Scala list into a Java util list and specify a schema. This allows you to go ahead and create a data frame like you want. So let's see how to do that. So now I'll create a new row, and inside that row, you'll use the Spark session and then say create data frame. And now we can go ahead, use a list of object again. We can say a list. Let me copy the sequence of object that we had here. Let me just put it here like this. Usually this will also just create a data frame for us. If we do something like this, we'll go ahead and do the same thing as previously. But now we would like to specify the schema of the data frame manually. For example, right now, if you take a look in here, you will see that the number 1 is being defined as an integer. But what if you would like it to be defined as a long type? And this is exactly what I'm going to do now. We go ahead now, we need the schema of the data frame, as we can see here, has to be defined as a struct type. So, but before we can use struct type, we must import Apache Spark type. So let me do the following: import org.apache.spark.sql.types. And this will import the types. Now we can define a struct type. So a struct type is a list of struct field, and a struct field contains the name of the column, the data type of the column, and an information whether the column can be null or not. So let's do that. Struct type. Now we need a list of struct fields. We will say the name of the column should be key, the type of the column should be long type, and it can be null. And then we say true, which means, of course, this is false. It will be quite bad to have an ID that can be null. And this is it. So this is the schema of our data frame, but only for the first column. Now we also have to define the name, the schema of this column, of the second column. So we do the following: list, again, a struct field, sorry, not list, but now what is happening? Yeah, this comma has to go away. Now I define another struct field. We will say it's the name, and it's of string type, and it can be null, for example. Good. And this is all we need at first. Now we take a look here again. This is awaiting a Java util list and a struct type. So the struct type is okay, but now what we have in our source code is a Scala list, but not a Java util list. So we'll have to convert this list into a Java util list. To do that, we will import Java converters. So I'll go ahead, do import Scala dot collections dot Java converters. This one. execute the cell on close block, execute that cell, and now I can transform this Scala list into a Java util list using the sjava function. Now we have a list, a Java util list, and a schema in the form of a struct type. And now we can go ahead, execute that. What is happening? Let's take a look into the definition again. This is a list of row. Sorry for that. So what I did here, I only sent a list of object, but we need a list of row. So let me put a row here and another row here. And then we can convert that and execute it on close block. And this create a nice data frame for us. And we can see that the key is now of type long and the name is of type string, which means this is how you can create a data frame manually in Apache Spark using a list of objects. In this case, the object is a row one. So the row is how, so a data frame is made of rows, and a row has columns. So this will be the columns of the row. This is how this looks like. Now you can take a look. Let me give this one a name like this. We execute that, and we can do the following. We can do df1.print schema to take a look into the schema of the data frame. You can see that the key is of type long and the name is of type string. We can easily change that back to integer type here, like this. Execute this again. Now down here, if you do the same, like df1.print schema, you can then see that the schema was changed from long to integer. So this is how you can create data frames manually in Apache Spark. We have two options. We can use a range of number, or we can specify a list of row objects and then specify the schema manually. This is my favorite way to do it, so that I can just create a row of different objects. What I can also do, I can do something like this, 1.1 and 2.2 for example, and add another field to it, as simple as that. And then I say this is of type double type, and Apache Spark will just go ahead and create a data frame for me. So, and the other way we saw earlier was how we can just turn a standard range of number into a data frame. So if you like to learn more about how to create data frames in Apache Spark, or how to work with Apache Spark in general, check the description below. I also have a course on Udemy that you can use the link below to enroll in it if you want, for less than $10. Thank you for watching.